Welcome back, Essentials, to the This Week in Geology series. So this is going to be episode 2, and obviously it is pretty apparent that you guys like the unedited version, so let's just jump right into reading the articles. So the first article that we are reading today is about EIA's AEO 2021 shows U.S. energy-related CO2 emissions is rising after the mid-2030s. In the U.S. Energy Information Administration, EIA, Annual Energy Outlook 2021, EIA projects that U.S. energy-related carbon dioxide emissions will decline for most years throughout the mid-2030s, but then begin to rise slightly from the mid-2030s through 2050. In the AEO 2021 reference case, EIA projects that by 2050, U.S. energy-related CO2 emissions will be 5% higher than 2020 levels. EIA's assumption related to domestic oil and natural gas supply also affects emissions projections. U.S. energy-related CO2 emissions increase in the high oil and gas supply case because natural gas is assumed to be more abundant, less expensive, and therefore more competitive with renewable energy sources. In the low oil and gas supply case, domestic resources are assumed to be limited and natural gas is more expensive than and less competitive with renewables. EIA's renewable cost assumptions affect emissions projections as well. Emissions increase in the high renewables cost case because renewables are relatively less economically competitive with fossil fuels, especially natural gas. In the low renewables cost case, relatively lower renewables costs lead to a larger renewables share of the total electricity generation mix. And you can see on this chart, this is us right here. We had a spike, in about 2018, 2016, and then it dropped pretty significantly into 2020, which is probably related to the quarantine, honestly. And then the projections are that it's just going to gradually rise. And then in terms of carbon dioxide emissions, based on, the situation where the economy improves, which honestly, I would prefer the economy improve, they expect the CO2 to increase significantly, which makes sense because, more people will be driving to work and there will be more people working, more jobs, more people working in energy related. Like they were saying, if oil and gas does make a comeback, that would be probably part of the high economic growth. So obviously, as an American, you want to see the economy go back up because it's in shambles right now. Let's move over to UAE's space probe. Amal enters Mars orbit. The feat makes UAE the 5th space agency to reach the planet, while its plans for a Mars settlement by 2011-17. Nice. So the United Arab Emirates first mission to Mars has entered the red planet's orbit after a seven-month 494 million kilometers or 307 million miles journey, allowing it to start sending data about the Martian atmosphere and climate. To the people of the UAE, to the Arab and Muslim nations, we announce the successful arrival to Mars orbit. Praise be to God. Amal had to perform a series of turns and engine firings to maneuver into orbit, reducing its speed to 1200 miles per hour. Wow. From more than 75,000 miles per hour. That's insane speed. Tuesday's announcement makes UAE's space agency the 5th to reach Mars. The Mars program is part of the UAE's efforts to develop its scientific and technological capabilities and reduce its reliance on oil. Its space agency has a plan for a Mars settlement by 2011-17. It aims to provide a complete picture of the Martian atmosphere for the first time, studying daily and seasonal changes. That's really freaking cool. My university does a lot of research, remote sensing and GIS type work on, not on Mars, but of Mars, and it's pretty interesting that we are reaching the point where we possibly could start flying to Mars. Like 7 months to get there. So congratulations to the Arab, what is it called? the United Arab Emirates. That's awesome that they reached it, and that was before NASA. So, well, I mean, NASA has been there with a probe, with a rover. So, it's amazing the amount of speed that they have to get there in 7 months. It just makes you feel so insignificant when you see something like this. 75,000 miles per hour over 7 months, and you're able to get there in 7 months. That's just mind blowing, and that's why I wanted to read this one, because it was anything related to Mars I definitely want to know about. Trading surfboards for snowboards. So as you guys can see, Mauna Kea and Mauna Loa in Hawaii, it has snow caps, which is actually really cool. Snow is not as rare as you might think in the Hawaiian Islands, but it never stops being beautiful. On February 6, 2021, the OLI on Landsat 8 acquired natural color images of the Big Island of Hawaii with abundant snow on its two tallest peaks. Nearly every year, Mauna Kea and Mauna Loa, elevation above 13,600 feet, receive at least a dusting that lasts a few days. Sometimes, like this year, it is more like a winter blanket of snow. The bar chart below shows the normalized difference snow index for Hawaii as observed by the NASA's Terra satellite. NDSI incorporates a blend of visible light and shortwave infrared to assess the amount of snow within a given geographic area. This chart shows the combined NDSI for Mauna Loa and Mauna Kea. Mauna Loa is in teal and Mauna Kea is in blue for the first week of February in each year from 2001 to 2021. The combined weekly NDSI in 2021 for the two volcanoes is the highest since 2014 and the second highest in the record. Snowfall in Hawaii is often associated with a weather phenomenon known as a kona low. Winds that typically blow out of the northeast shift and blow from the southwest. The winds from the leeward of or kona side draw moisture from the tropical Pacific, turning it from rain to snow as their air rises up into the high elevations. With the recent snowfall in Hawaii, Florida is now the only state that has not seen snow this winter, according to the Weather Channel. So as you can see, the it's really up and down, inconsistent. But you had your spike in 2014, like they said, and then in 2021, which is this bar graph right here, Mauna Kea is just a little bit higher in terms of the snow difference. So that's pretty cool, pretty interesting. Krakatoa. So Krakatoa is still active, and we are not ready for the tsunamis another eruption would generate. The August 1883 eruption of Krakatoa was one of the deadliest volcanic explosions in modern history. The volcano, found in the middle of the Sunda Strait, in between two of Indonesia's largest islands, was on a small island which disappeared almost overnight. The eruption was so loud it could be heard in Reunion, some 3,000 miles away. As the volcano collapsed into the sea, it generated a tsunami 37 meters high, tall enough to submerge a 6-story building. Holy crap. And as the wave raced along the shore of the Sunda Strait, it destroyed 300 towns and villages and killed more than 36,000 people. Nearly 45 years later, in 1927, a series of sporadic underwater eruptions meant part of the original volcano once again merged above the sea, forming a new island named Anak Krakatoa, which means child of Krakatoa. In December 2018, during another small eruption, one of Anak Krakatoa's flanks collapsed into the ocean, and the region's shorelines were once hit again by a major tsunami. This time, 437 were left dead, and nearly 32,000 were injured. More than 16,000 people were displaced. Even though Anak Krakatoa had been active since June that year, local residents received no warning that a huge wave was about to hit. This is because Indonesia's early warning system is based on ocean buoys that detect tsunamis induced by submarine earthquakes, such as those that struck on Boxing Day in 2004, and one of the most deadly natural disasters of all time. Yeah, that one was bad, horrible. But tsunamis caused by volcanic eruptions are rather different, as they aren't common, and scientists still don't fully understand them. And Indonesia has no advanced early warning system in place for volcano-generated tsunamis. At some point in the future, Anak Krakatoa will erupt again, generating more tsunamis, and since it is difficult to predict exactly which areas of the Sunda Strait will be affected, it is of paramount importance that residents in coastal villages are well aware of the danger. An advanced early warning system could be installed. It would involve tide gauges to detect an increase in water level, satellite imagery, and drone mapping, and a tsunami numerical model run in real time. When this system triggered a warning, it would be fed direct to residents who live in the coastal belt. Until such a system is in place, it will be vital to get the local community involved in disaster risk management and education. We don't know exactly when Krakatoa will next erupt or if any future eruptions will match those of 1883 or even 2018. That's a question for volcanologists. But we should do what we can to prepare for the worst. Yeah, hopefully they're able to develop an early warning system for this volcano that could potentially go off. I am going to look up the recurrence interval for this earthquake and see how many times it's actually erupted in its history. All right, so this one's from Science Daily. A billion years and 40 seconds. Video reveals our dynamic planet. New research helps understand how plate tectonics power life on Earth, which honestly, they probably play a very, very significant role because during the Paleozoic, the Permian, there was a huge extinction pretty much due to plate tectonics. Geoscientists have revealed a video that for the first time shows the uninterrupted movement of the Earth's tectonic plates over the past billion years. The international effort provides a scientific framework for understanding planetary habitability and for finding critical metal sources needed for a low-carbon future. It reveals a planet in constant movement as land masses move around the Earth's surface, for instance, showing that Antarctica was once at the equator. So yeah, Antarctica was once at the equator, and that was using Glossopteris, I believe. I'll look it up and I'll post it on the screen. There was an index fossil that allowed them to determine that not only would and this was my favorite scientist of all time is actually Alfred Wegener. Alfred Wegener, he's actually my favorite scientist of all time because he helped basically inspire the research into plate tectonics. He came up with continental drift, but he couldn't explain how the plates were moving. He just could explain that at one time they were together based on index fossils and similar rock outcrops and, a bunch of different things, a bunch of different features. And he used an index fossil to determine that Antarctica was actually at the equator at one point because it had a fossil on it that was only at the equator, or at least in that general portion of the Earth, I should say. Earth scientists from every continent have collected and published data, often from inaccessible and remote regions, that Dr. Andrew Meredith and his collaborators have assimilated over the past 4 years to produce this billion-year model. It will allow scientists to better understand how the interior of the Earth convects, chemically mixes, and loses heat via seafloor spreading and volcanism. The model will help scientists understand how climate has changed, how often currents altered, and how nutrients fluxed from the deep Earth to stimulate biological evolution. Simply put, this complete model will help explain our home, planet Earth, and became habitable for complex creatures. Life on Earth would not exist without plate tectonics, which is very true. With this new model, we're closer to understanding how this beautiful blue planet became our cradle. Yeah, I've seen this before. This is pretty cool. About 250 million years ago, that's around the time that the Paleozoic was coming to an end. Yeah, and it is like watching a dance. It really is. And now the dinosaurs are in existence there, and now they're extinct, and now it's a little bit accurate. Okay. All right, so the next and final article of this episode is how rocks rusted on Earth and turned red. Well, I would think that would be based on the iron, but let's read this. Important phenomenon could assess future climate change. This one's from Rutgers University. It was posted on February 8th, 2021. So in summary is how did rocks rust on Earth and turn red? A new study has shed new light on important phenomenon and will help address questions about the late Triassic climate more than 200 million years ago when greenhouse gas levels were high enough to be a model for what our planet may be like in the future. All of the red color we see in New Jersey rocks and in the American Southwest is due to the natural mineral hematite, the iron. As far as we know, there are only a few places where this red hematite phenomenon is very widespread, one being the geologic red beds on Earth, and another is the surface of Mars. Our study takes a significant step towards understanding how long it takes for redness to form, the chemical reactions involved, and the role hematite plays. Oh, okay. I remember learning about hematite being the reason, that red bluff granite would look red, or a certain granite will turn red, is because of the hematite in it, the iron. And then the yellows come from limonite, and the greens and like a shell could be from the iron, weathering a certain way, chemically weathering, of course. So this research challenges conventional thinking that hematite has limited use for interpreting the ancient past because it is a product of natural chemical changes that occurred long after the beds were initially deposited. Lepre demonstrated that hematite concentrations faithfully track 14.5 million years of late Triassic monsoonal rainfall over the Colorado Plateau of Arizona when it was on the ancient supercontinent of Pangaea. With this information, he assessed the interrelationships between environmental disturbances, climate, and the evolution of vertebrates on land. The hematite is indeed old and probably resulted from the interactions between the ancient soils and climate change. This climate information allows us to sort out some causes and effects, whether they were due to climate change or an asteroid impact at, I'm going to butcher that, Manicouagan in Canada, for example. For land, animals, and plants, when the theropod dinosaurs, early ancestors of modern birds and Tyrannosaurus rex, were rising to prominence. The scientists, in collaboration with Navajo Nation members, have submitted a multi-million-dollar grant proposal to retrieve more cores at the Colorado Plateau that will include rocks known to record a very rapid atmosphere change in carbon dioxide, similar to its recent doubling as a result of human activity. So they believe that there is a correlation between hematite and, the production of CO2 right now. They also are trying to understand the true importance of hematite, and I get what they're saying, that we've always viewed hematite as kind of a recent type thing, a recent process during the weathering process of a rock that will contain a lot of hematite, a lot of iron. They're trying to explore it in a way that allows you to tell more of a story of a certain type of rock, in this case late Triassic in the they're talking about Arizona, which, yes, that place, Arizona, Utah, there's a lot of red rock in that area. Okay, so it's New Jersey, not New York. Rutgers is in New Jersey, so derp. That's a pretty interesting development. If they can make importance of hematite, there's a lot of hematite in the rocks around me. It'd be not something I'm gonna go study on my own, but that would definitely be an interesting project for anyone. Trying to understand the hematite and seeing if the like the granite we have here could be the hematite in it could be used to kind of understand the climate in El Paso. That would be pretty interesting. So I hope you guys enjoyed this episode. It seemed that episode 1 did pretty well, so I'll keep doing this series, and I'll edit it and try and make it as interesting as possible and not just me reading the articles to you. I will also include pictures and maybe some videos and stuff like that. Some definitions will pop in. Let me know what you want to see in next week's episode. If you see any articles, just submit them to me on the YouTube comments. Just submit them. And I'll see y'all in the next episode. Later, Essentials.